Hi, everyone, and thank you for attending today's webinar on the Swagelok Gas Distribution Program. My name is Craig Gifford, and I'm a Communications Manager here at Swagelok. I'll be serving as today's host and moderator. This webinar, led by Karim Mahraz, Swagelok's Product Manager for Analytical Instrumentation and Custom Solutions, will cover what a gas distribution system is, why it's important to make such systems a priority, their common challenges, the role of pressure regulators, and the benefits of using Swagelok's innovative solutions. Karim has led Swagelok's analytical instrumentation, custom and application solutions product line since 2014. Before that, he served as an applications engineer where he developed engineer-to-order fluid control systems by reviewing and interpreting the technical needs of our customers and creating specific solutions to meet those needs. He has also been a manufacturing engineer for our chemical and manufacturing operations. Karim holds a master's degree in mechanical engineering, as well as a master's degree in business administration. Before we begin, just a bit of housekeeping. In this Microsoft Teams live event, your microphones will remain muted. Additionally, we will be taking your questions at the end of the presentation. In the upper right-hand corner of your screen, you will see a Q&A bubble. When you have a question, please click that bubble and type in your question. It will be routed to me, and I will ask the question to Karim at the conclusion of the presentation. So with that, we are ready to begin, and let me bring Karim up onto the screen.
Thank you, Craig. And very excited to be here with you guys and share some of the details around gas distribution systems and also some of my expertise and the value that we bring here. In today's agenda, we are going to discuss a little bit an understanding of what a gas distribution system is, the importance of these systems and why we should make them a priority in our gas distribution systems, the benefits and advantages that these systems play within any applications or overall within your facility, the role of some of the basic components that are crucial within these systems, and that bring the value of the performance for these systems. And lastly, we'll highlight some of the design standard that Swagelok has developed that kind of we feel are very important and address a lot of the customer challenges. And lastly, at the end of this presentation, I'll be happy to take on some of your guys' questions. So let's start by looking at what's a gas distribution systems. These systems play a crucial functions for many industries. They work to deliver gases from high pressure sources to the facility at the pressure and flow rate required by each of your applications. They are designed to provide precise and safe delivery of high pressure, toxic, corrosive, and flammable specialty gases in some cases. These gas distribution systems, we know that they are crucial in many industrial applications where they need precise control of the pressure itself, and the control is either done at local storage units or in some cases at the point of use like the lab, etc. There are multiple locations in industries where gas distribution systems are used. These systems play a series of critical functions within many industries, such as research facilities, lab, operation, process, and productions plants. For example, within chemical refining, analytical shelters, as an example, where they analyze multiple process gas. They need to control the calibration gases such as nitrogen, helium, or hydrogen that might be used as a carrier gases with a gas chromatograph or GC. So the purity of these carrier gases is critical. The gas sensors, as we know within analyzers, can occasionally drift from the set specification, and the calibration gases play a critical functions or role in restoring the accuracy and the detector through frequent and proper calibrations. gas distribution systems can play different functions and can be used for different purposes. Some customers may have a need to use gas panels based on the applications, the functions and needs. And to list a few of these systems or the applications, they can be, for example, used as an access point for gas supply systems. They can also help to maintain the purity and the quality of the gas. And also they can reduce the source pressure to a lower constant pressure desired by the applications or the system itself, enable an uninterrupted supply, and we're going to go over some of those examples, a handling of reactive, toxic, and corrosive gases in some cases, and also sometimes just proper handling of expensive gases, specifically like for semiconductor applications or some crucial applications where you need to control precisely those measurements. Overlooked, we know that there are some issues with these systems can result not only on the loss of gases, but also on the loss of process efficiency, downtime, and ultimately, in some cases, the safety of the operator. So when systems operator is not really intuitive, when leaks are a concern, or when your gas panels are difficult to service, that's where we think the time we need to take actions to avoid these compounding costs, I call them. The one thing to keep in mind is that with any applications or process, safely, reliably, and effectively delivering gases where they are needed, provide the foundation of a well-performing operations. There are some definite advantages that gas panels offer for any customers or, within their operations, their applications, or industries. First and foremost, it's the safety. These systems need to ensure the safety and well-being of systems, but also the operators and all the team members. So when setting up a system or a gas distribution system in a lab or any other type of facility, the safety of all personnel must be taken into consideration. So these systems need to be designed to reduce potential of gas leaks and maximize the operator safety. They are critical and need to be assembled and tested prior to being placed in service for sure. Additionally, these systems need to be designed and labeled to both be easy to understand and safe to use by the operator. The second element, it's more increase the uptime and process accuracy and repeatability. So the design and quality of any gas distribution systems help ensure the reliability and the uptime of any instrument. They need to allow and be easy to maintain and troubleshoot and to keep the system reliably delivering kind of the pressure and the flow required by each applications. And the third element, which is focus your time and resource when you need them most. So these systems need to be it's ideal to have them pre-configured, assembled, and tested. Will help kind of limit the need for you to build these systems on site, but also allowing your specialists to focus their effort elsewhere. So the reliability of these systems can also lead to a reduced need for maintenance, saving you additional time and resource. And the last element, which is reduce the cost by avoiding leakage and unplanned maintenance. Gas distribution systems help maximize the efficiency of gas uses and also minimize the cost of leakage. Assembled prior to delivery with leak-type component like the Swagelok one and be able to test it, these systems are constructed to provide long-lasting performance while helping you reduce the operating cost. In general, gas distribution systems are complex systems. If not designed and built properly, they can also have an impact on the end process and lead to consequences such as erroneous in reading, inconsistent process result, system failures, etc. Not to ignore the challenges with gas leakage and wastage, which further amplify the unwanted losses that we just went over. The fire triangle, or sometimes it's something that I know a few, or if not all of you, have usually come across in school. The fire triangle, and sometimes it's referred to as the combustion triangle. This is what I consider a simple model for understanding the chemical reaction which may occur to create a fire in any gas systems. For example, let's look at an oxygen systems. The primary hazards for oxygens are kind of the high pressure cylinders, and they're typically in the range of 2200 psi, and some are in 3600 psi. So gas pressure systems are built from materials such as brass, coppers, and in some cases stainless steel, soft seal material like Teflon, etc. All of these are form of what I call them fuel in an oxygen environment. But its very composition and oxygen gas handling systems has two of those required three legs that you see in the triangle, namely oxygen and the fuel. So the safety of the operators and your plant and facility will depend on our ability to control the heat or the ignition source within these systems. As such, these systems need to be kind of designed using safety in mind by selecting the right material, using high purity or high quality cleaned to certain standard products, leak tight, and then they need to be tested prior to installations to help ensure less time is needed to troubleshoot and ultimately improve the safety of the operators, but also the plant as a whole. First, you may ask me why anyone would use 2 bottles or more. Well, the simple answer is so you don't run out of the gas or the media that you're trying to use within your applications. So when one bottle stop, you can switch to the other one and get the one empty swapped or changed. By depending on your system, switching between those 2 bottles can be done either manually or automatically using a changeover systems. These systems kind of are designed to provide continuous supply of gas from 2 or more sources containers. So let's take a look closely at these systems and understand better the pros and cons and how they functions. So with the manual changeover, system operators need to manually kind of reset the system when the first bottle is empty. The changeover has a lever which must be kind of set to the bottle in use. It requires more involvement from the operators. You will have more interruptions to your process when bottle is empty and need to make the bottle change. So maintenance is always needed here, and an interaction with the operator and with the systems need to happen constantly. And the big challenge also as well is the premature change out. So sometimes you go on the field and you assume that the bottle is completely empty and you don't take on the risk of letting it run out. So you kind of waste some of the gas that are left on the bottle itself. Or also sometimes the failures is you constantly can run into those challenges. With an automatic changeover, the bottle will switch, or the system will switch from one source to the second source when it's empty. It allows the user to deplete the gas in the container without the concern of gas outage and wasting of unused gas as a result of premature changeout. When one source is empty, as I mentioned, the changeover system automatically draw from the second source, and the first source can then be changed without an interruption to the process or the pressure of the system. Lastly, we know that there is an increase on use of all type of gases, and that's mainly driven by the process requirement for all manufacturing processes. But in order to achieve and maintain the system integrity and performance, the selection of appropriate filters is absolutely essential. As we know, the main source of particles are industrial gas components used within these systems, such as the check valves, thread connections, ball valve, tanks, pumps, and in some cases it can be also the environment where these systems are installed. Though they are crucial to the process, these components may release these particles flowing inside an installation as they were. So to mitigate those risks, we need to install a filter to help capture those particles. But the big question is, how do you choose the right filter? When dealing with filters, we know there is a variety of options out there, but there are some basic criteria that we need to pay attention to when choosing that filter. that's suited for your applications, such as the filter component, or I call it the element, the size, the material of constructions for both the element, but also the housing. As such, I think we need to keep in mind that the selection of the filter need to match the task at hand. Also to note, in general, regulators are susceptible to damage from system particles. And it's important to look closely at the design of any pressure reducing device. And at a minimum, they should be equipped with some sort of filter, usually press-fitted, as you can see on the image here. But at best practice, it is to install an upstream filter to protect the component, but also the system integrity. So let's take a look at some of the fundamental of gas distribution systems, and specifically a key element or product in these systems. Regulators come in all shapes and sizes, but there are a few terms and definitions that we feel are important to understand and look at closely when dealing with regulators. A regulator play a crucial role in these systems, and kind of is the I call it like the shining star within these systems, and they are not easy also to define or describe in one sentence. But the key word that we need to keep in mind is pressure. So a pressure regulator is a mechanical device designed to control the system pressure in response to an upstream or downstream pressure change. Regulators are used for gas and liquid and can be integral devices with a pressure settings, a restrictor, and a sensor all in one body, or consistent of a separate pressure sensor, controller, and flow valve. Something to keep in mind when dealing with regulators is that there are two types. Downstream pressure changes are controlled by what we call a pressure reducing regulators, which will act as a control valve that reduce the input pressure of a fluid or gas to a desired value at its output. But also the upstream pressure changes are controlled by what we call a back pressure regulator, which is another control valve that maintains the set pressure at its inlet side by opening the flow, or by allowing the flow when the inlet pressure exceeds the set value. As I mentioned, when dealing with gas panels, we need to correctly size and select a pressure regulator because it's crucial or a critical component of a properly functioning gas distribution systems. Every gas regulator has a flow curve that describe its operation range. The flow curve is important to look at, and it helps us to determine the useful regulating capacity of that regulators, and mainly they have three sections. The first section, which is the seat load or lockup, indicate the pressure above the set point required to completely shut the regulator valve and prevent the gas flow. When too much pressure build up, the regulators kind of close that pocket that it have within its body. The second one, which is the ideal operating range for the regulators or for that system, is the area below the flow curve, where the regulator provide the greatest control range. And lastly, which is the choked flow, which is a limiting condition where any reduction in downstream pressure will have no effect on the flow rate for a fixed upstream pressure. In this case, the regulator's valve is fully open and is no longer kind of regulating the pressure, and it is more acting like a valve that just basically lets the flow go through. Now that we understand some of the design characteristic along with some of the decision factor, let's take a close look at what we at our standard design and some of Swagelok, what we consider the best practices for gas distribution systems. We have segmented our gas distribution systems into 4 main modular gas panels, making it easier to control the gases at the point of use when a gas source is located remotely, provide a practical way to regulate and control specialty gases at the process point or locations of GC, for example, when gas are stored in remote locations. These systems have been designed with the safety in mind to reduce the potential of gas leak, but also protect operators, built with minimal thread connections to avoid leaks. And that's something that, as I mentioned earlier, leaks can can affect the performance of these systems, but also can have an impact on the process itself. Intended to help maximize the gas uses and are highly configurable, fully assembled and tested prior to delivery to ensure the reliability performance, easy to maintain and troubleshoot. So that's something that we take pride of, and all our systems are taken. We have taken into consideration how to make them as easy to operate from the operator standpoint, but also to maintain and service. Assembled using high quality products, as you guys know, designed and labeled for standardization to reduce training needed and make the operator or the operation safe and easy to understand. And lastly, all of our systems will come with that Swagelok limited lifetime warranty to give you that peace of mind that you all have experience with Swagelok. So let's look at what we call a source inlet connection. These systems are intended for installations where there is a heavy use of gases or where extra control is needed prior to the primary gas control systems. A source inlet are pretty basic, but play crucial roles in helping managing your gas source. These systems typically include isolation, vent, and purge options. Additionally, these will typically have be connected through a hose to the bottle or hard tubing or pigtails to connect each bottle to these type of manifold. A few additional benefits of these systems, the ability to isolate individual gas bottles entirely or the entire manifold to maximize the safety. They are definitely configurable with bottle spacing to accommodate wide range of bottle storage methods within your facility. And also there is some tagging capabilities where you can tag them to identify which gas is connected to that bottle itself. Or also you can also document some of the service aspect that has been done on those bottles or the system itself. The second one, which is the primary gas control systems, SGP. These systems is used predominantly to reduce gas pressure at or near the source prior to a larger gas distribution network, with many variation possible within a standard footprint. Each of these systems can be kind of configured to meet specific needs while being easily integrated into an overall installations. So being the first point of control, these primary gas control systems can also be built with either a single or dual stage pressure regulators to accurately kind of deliver gas while minimizing the supply pressure effect and providing the ease of use dependent on each needs. Additionally, this system can be integrated with options such as vent, purge, and relief options as well, and can be incorporated to enhance that safety aspect that we talked about. A few additional benefits is these systems are designed to easily be serviced and do any maintenance that's needed, helping minimize the downtime if maintenance is required. The upstream and downstream pressure indicator provide ways to kind of conform or confirm the system is performing as designed. And lastly, long service life, which is further improved when paired with one of the source inlet that we just went through. The third one, which is a changeover system, which is, as I mentioned earlier, they provide continuous flow of gas and liquid to your applications. So when the primary source is empty, these changeover automatically, they have been designed to switch to the second supply. Though they eliminate the pressure fluctuations as well, the outage of wasted gas, the outage of running out of gas, but also the premature change doesn't happen as well. When one source kind of empty, the changeover will draw or start drawing from the second source, and the first source can certainly be changed or replaced. These systems include high pressure inlet and vent valves, allowing for isolation and complete removal for any entrapped air or after the cylinder change out. Additional benefit is eliminate the cost of downtime by providing constant uninterrupted flow, can be integrated with purge optimization, can be designed and offered for oxygen service as well. And we have done quite a few of those for some specialty gases where it's crucial to maintain the supply of those gases to your operations, and can be also integrated with pressure switch alarm, and also we can be fully automated to monitor the health and or the performance of the system as well. The last one that we have here for the systems overview is we call them the point of use panels. And these systems have been designed to provide practical way to regulate and control gases at the process point or location of equipment. So when gas are stored in remote locations, they are intended to also to be kind of as the final control device in the gas distribution systems. These systems can be incorporate multiple products and features to help protect the integrity of lab gases, for examples. And as I mentioned, you can see some filters there, and that's more to help protect the systems and eliminate any contaminations, protect the lab equipment, and ability to also control multiple gases in a small footprint. So you might ask us what type of documentation we provide with each of these systems, and first and foremost is each of these systems will come with a user manual. We need to make sure that every component is properly identified and operators know exactly what to do when interacting with these systems. So helping the operator and anyone that might have to service the panel with the information they need at the place they need it. Beyond that, of course, we provide sales drawing for each of these systems along with a bill of material, and potentially we can also provide a spare part if needed. So whatever you need to satisfy your needs in general. Overall, we are pretty flexible there in terms of documentation, but at minimum, these are the type of what you should expect or receive with these systems. Lastly, let's take a look at our part numbering structure, which is very unique to Swagelok. And this is what I call is a smart part numbering configurator that allow you kind of to fully configure a gas distribution systems for your applications. You can make your selections and design a specific systems using this tool. Once you have made your selections, and if you have multiple locations regionally or even globally, you can rest assured that once you select that part number, it will be the same no matter what, whether you order it here in the US or in any other regions. Even if you have a need for any customizations, this is kind of what I call a great communication tool that you can use to work with our sales and service centers, where you can say, I need this. Minor changes, they can be as change of the pressure gauge, the routing of the tubes, or some specific component. We can certainly accommodate those, or it can be also used as a tool to communicate major changes. Basically, you create a basic configurations, and then but you need a complete layout or change of the system's configuration. This is kind of what I call a great tool to kind of help communicate and interact with our sales and service center so they can support and understand better your need and provide you the ideal solutions for your applications. Lastly, our team will design, as I mentioned, and assemble and test the solution to your specific applications or need that will provide you with the lasting performance. When systems sleek are tight, easily configurable, and ultimately reliable, you can, as I mentioned, maximize the uptime and allow your team to focus on other priorities. We have established a series of services to help you assess and look closely at at your current existing systems and applications, where Swagelok and our sales and service center advisor will work with you to assess your current or future applications, which might include component analysis, on-site support, or even professional training with hands-on instructions, and tailor a solution that meets your business kind of requirements. So please take some time to look at our available product and services that are currently available to you through our sales and service centers. And there are a few links there that you can reference, and you can see all that content. So that will conclude our training. I'll be happy to take on any questions that you might have.
Great, thank you, Karim. Just a reminder, we'll take questions through the Q&A button that is in the upper right-hand corner of your screen. It looks like two little bubbles with a question mark in there. So if you have a question, please click that, type your question in, it'll come to me, and I'll route it and get it out to Karim and kind of just read those out loud. And we already have a couple that are coming in, Karim. So let me give you one to start with here. Are there any options for corrosive environments other than stainless steel?
Yeah, that's a good question. So definitely there are multiple options out there, and we have those. Depending on the applications, depending on the media, depending on the rating and everything else. So what we are going to do is basically work with you to understand better the application parameters, I call them, and then we make recommendation of what product or what material are suited for that specific applications. And our sales and service center are definitely have the capabilities and the knowledge and the understanding on how to select the right material and product and make some recommendation out there. So definitely there are options out there like Menel, Hastelloy, brass, etc.
Great, thank you. Our next question, does the inlet filter to the regulator suffice, or will I need external filtration ahead of the regulator?
Great question. I think depending on your systems, in general, I recommend installing an upstream filter, and that's more to capture like large elements and everything else. I think that press fitted filter that you saw on the slide there, it's more of a secondary protection for the regulator itself and help capture any other element or particles that might be that might kind of escape from the second filtration. But also, I don't think it's sufficient, but I think it helps protect also the regulator itself. But definitely we recommend installing an upstream filter.
Great. Next question, you showed the flow curve for regulators. So the maximum flow in the event of a regulator failure can be considered the zero output pressure flow? He's looking for clarification on that.
The maximum
flow in the event of a regulator failure can be considered the zero output pressure flow.
No, it will be a fully pressure. So in case of a failure of a regulator, you will have it will be just an open valve, for example. So you will have the full pressure range. But like I said, most of this regulator won't fail completely open, I should say. But in that case, if there is a major failure on the regulator, it's basically not doing any functions anymore and acting as a valve. So depending on the failure mode, that's what dictate what pressure or what scenario we'll run into.
Okay. Next question: does Swagelok have pre-engineered solutions for all applications, or how would that work? Is there a pre-engineered solution for everything, or is it case by case basis where you have to get in, look at the application, and then build a solution for that?
That's a good question. In general, we feel like the 4 standard that you saw will provide you with a holistic view. So when we developed those solutions, we kind of took the customer feedback and we learned more about the applications and needs. And we think those capture significantly amount of applications, but we know each application is unique. And those platforms, those 4 standards represent kind of the base, the platform to design the ideal solution for your applications. So there is not I'll say there is not one solution that can fit everything, but we think those solutions can be the base that can be kind of adjusted to fit any specific applications.
Yeah, oh, great. Our next question, have you ever seen a gas purged seal set with the flow regulator upstream of the pressure regulator? And if so, has it worked?
Can you repeat that question?
Sure, not a problem. Have you ever seen a gas purged seal set? Gas purged seal setup with the flow regulator upstream of the pressure regulator? And if so, has it worked?
In general, I think that's mainly like for the needle valve example. And in general, needle valve or any device that control the flow can cause significant pressure changes and always drop pressure, sometime more than we might expect. Something to be mindful of is that the change in the upstream pressure will affect the flow rate through the, like for example, a needle valve. It really will come down to which characteristic you want to control with precisions, the flow rate or the pressure. So if you want to control the pressure more accurately, then the needle or that device should be installed upstream of the regulator, for example. If you want to control the flow more accurately, then the needle valve should be installed downstream of the regulators. But if you need to control both accurately, then the ideal solutions or recommendation would be to have a two-stage regulator and with the needle kind of installed between those two stages. So it will come down to what exactly you're trying to achieve at the end.
Okay. No, great. Actually, we have a couple other regulator-related questions, and one very similar to what you were just talking about. Can you explain more on the benefits of a two-stage regulator versus a one-stage regulator?
Yes, really good question. With respect to when to use a single or dual stage, like I mentioned, it would depend on the applications and what you're trying to do. A two-stage will help kind of eliminate the supply pressure effect risk that you might run into. A single stage also can be sufficient, but also it would depend on what you're trying to achieve and the parameters of the systems. But in general, like the two-stage also can help mitigate some of the risk of the pressure, the supply pressure effect, but also the Joule-Thomson effect, for example, is another risk that you might run into. So, like I said, it all depends on the parameters, the applications you have, and that's where our sales and service center can help kind of define and recommend the solutions that's ideal for your application.
Okay, no, great. Another regulator-based question. So when using a pressure regulator, how should flow control be accomplished? Is it before or after the regulator?
Well, the regulators control pressure, and so I'm not sure I understand the questions. If you can repeat that.
No, no problem. When using a pressure regulator, how should flow control be accomplished? Is it accomplished before? Is it set up before or after the regulator?
So I think that tie into my previous answer with respect to flow control, and ultimately it would come down to what you're trying to do. Is trying to control the flow range, and that in that case, if you want to be more accurate on the flow, then the needle or that device will need to be installed downstream of the regulators. But if you want to control more the pressure, then the needle valve or the device needs to be installed upstream of the regulator. So it all depends on what you're trying to do here. But like I said, it depends on what you're trying to achieve at the end, and that would dictate which approach we should go with to achieve those results.
Okay. Oh, great. When it comes to the Swagelok SCO, what indicates to the SCO that a cylinder or bottle is empty to cause the automatic changeover?
That's a great question. So there is a mechanical sensor. So there are two regulators that's basically looking at the pressure, and they are set to a changeover pressure, we call it. So when that set pressure in the source one kind of hit that set pressure, the mechanical design will automatically let the second source take over. If you are more asking about how you can monitor or get more visual indicators and stuff, there are other means which we can include, like pressure switches, but also some automation aspect where it can give you more visibility to when the pressure was changed, but also the state of the system itself with alarms, etc. So mechanically, the system operate that way, and we have developed ways to set the system so it changes at the pressure that you would like it to.
Oh, great. Another question here related to changeovers. The question comes in: the customer uses ultra high purity gases. So how do the systems handle changeovers in those environments or purging environments? Is it any different, especially with the ability to connect high vacuum with purging together?
Yeah, so definitely the system is going to operate like any other system. So regardless of the gas, it's more about the compatibility. I would say that's the thing that we should be more concerned about is, are those corrosive? Is there any compatibility aspect with the material that's selected for that system? But in general, the system should function as intended and will switch at the pressure designed for or specified for. With Persian and everything else, those are enhancements that have been integrated, and depending on how, for example, toxicity of these gases, we need to capture the purge aspect and make sure that it's disposed of in a safe mean or manner. And and in general, these systems, I think, will operate exactly like for any, regardless of the gas.
Okay, great. And along the same lines than this one, this might be a similar vein, but for our distribution systems, how reasonable is it to change supply gases for the system? For example, from nitrogen to helium?
Yeah. So for nitrogen and helium, I think the regulator will be a key element to look at in that flow curve I mentioned. So each flow curve with respect to a specific gas will change. But in general, regulators are designed to control them. So I think it doesn't really affect or matter. I think in general, these gas regulators will do its function as intended.
Okay. And great questions, everyone. Please keep them coming if you have them. Remember, there's a Q&A button in the upper right-hand corner of the screen. Just click that and it'll get routed to us. One last question that's currently sitting in the queue, Karim. In the event of a regulator failure, is there overpressurization protection that releases the excess pressure without stopping flow?
Without stopping flow.
Yeah.
So the pressure device, protection device, like a relief valve, for example, once the pressure exceed the set pressure, it fully open. And there are different relief valve. I think there is one that constantly relieve, and there is one that proportional relief valve. That means once it exceed that set point, it will open, and as the pressure reduce, it automatically shut off. And then so that I think will continuously flow once it starts diminishing, the pressure will get below the set point. So depending on the protection mechanism that you use, and that would dictate what result or what's the outcome that you will have.
That's great. Again, if you have any questions, please put them into the Q&A section. While we're waiting on to see if any more come in, Karim, if you can, just take another second and maybe circle back on the different services that Swagelok offers, or the kind of service Swagelok offers, to come and look at a customer's current system and setup.
Yeah, absolutely. So we have developed a team that we call that can certainly come on site and assess all your gas distribution systems. This team has been trained and certified and capable and have the expertise to come on site, assess and look at all your systems that you have identified as a potential or you would like us to assess. And at the end of that, that walk through these systems, the team will make recommendations and provide you with a full detailed report that will include, for example, recommendation on some enhancement to your system, will include some observations of some of the risks that you have within your current systems, and in some cases they will even make recommendation of some upgrade that you can include on your systems to enhance their performance, but also their safety aspect, etc. So our team that we have in place, and we can bring also other experts from the field to look at more advanced systems. But in general, our team will work with you to come on site, look at your systems, and make assessment and provide you with a full detailed report. And also the other thing that we have within our capability now, which is a virtual field advisory service, where one person can attend with a remote virtual device and will walk with you through the systems, or can provide you with that and you can walk through the systems, and they would ask a series of questions where we have our experts connected and ask and walk you through the system and ask for those questions to capture all the data and around your applications.
Oh, great. We did get one more question that came in. So this might be the last question we take here. So the flow curve for a regulator should state what the reference fluid is. That's the question. So the flow curve for the regulator should state what the reference fluid is. If this is the case, can you use a specific gravity correction factor to convert the flow curve values for other fluids?
So the first question is more with respect to, is every flow curve assigned to a specific gas? And the short answer, I'll say no. In general, those are kind of done by nitrogen or others. But if there is any specific gases that you would like to see flow curve, we have other capabilities where we can provide you with a specific flow curve to that gas. But in general, the flow curve is to give you some indications of the performance of that regulators with respect to any gas that you go through. And then the second part of the question
is, if that's the case, can you use a specific gravity correction factor? Can you use a specific gravity correction factor to convert the flow curve values for other fluids? So for example, convert a flow curve in air to argon.
Yeah, so like I said, there is other means or other tools that we have within our wheelhouse that does those behind the scene. I'm not too knowledgeable about the specific gravity to make those assessments, but definitely that's something we can follow up with.
Right. Well, it looks like that is all the questions. So I just wanted to, I'll bring myself back up so everybody can see me here at the end. So I just want to thank all of you for joining us today for our the Swagelok webinar on our gas distribution program. Thank you for all the questions. If you have additional questions, please be sure to follow up with your Swagelok SSC. They'll be reaching out to you as well to see that if you needed anything as well related to our gas distribution or any other solution that we can offer you. Again, we thank you for your time and we hope you have a great day. Enjoy.